All right, if you're wrangling AWS infrastructure, you know the struggle, right? Trying to keep everything consistent, secure, and, well, not a complete mess. In this explainer, we're going to tackle that head on. We'll show you exactly how to use Terragrunt to manage a ton of AWS accounts from just one repo. And the best part, we're building the security guardrails right in from the start.
So let me paint a picture. See if this sounds familiar. You've got your dev, your staging, your prod, and for every single one, you're just copying and pasting the same Terraform code, maybe tweaking a variable here and there. I mean, it works, kind of, but let's be honest, it's a house of cards just waiting for a breeze to knock it all down. And that's the scary part, right? What happens when that breeze comes? One little typo, one missed line in that production copy, and suddenly you've got a security group wide open to the internet. We've all had that nightmare. This whole manual copy-paste thing, it's just a recipe for disaster.
Okay, but there is a much better way. The solution is to stop the madness. Let's manage all those accounts from one single repository and build security in from the very beginning. And that's exactly what we're going to do with Terragrunt. Stick with me, because by the end of this, you'll be deploying seriously hardened infrastructure with one simple, safe command. All right, before we jump into the code itself, let's get the lay of the land. Here's the blueprint for how we're going to structure our entire infrastructure. So first things first, we're going to have separate AWS accounts for dev, staging, and prod. This is huge for isolating things. It means if something goes wrong in dev, it can't possibly touch production. And here's the kicker. Each account gets its own S3 bucket for the Terraform state and a DynamoDB table to lock it down. What does that mean? It means there's no way a developer in dev can accidentally mess with the prod state. No way. And the best part? Terragrunt handles setting all of this up for us automatically. And this whole setup lives in one single clean repository. The accounts folder, that's where we stick the variables that make each environment unique. The modules folder is for all our reusable Terraform code. Think of it like our box of Legos. Live is where we actually decide which Legos to deploy and where. And then at the very top, we have the root terragrunt.hcl. This thing is like the constitution for our entire infrastructure. It sets the rules that everything else has to follow. Okay, now for the really cool part, where the magic happens. We're going to crack open that root terragrunt.hcl file. This is the heart of the whole operation. It's where we write the rules, our security and consistency guardrails that every single deployment will automatically inherit. First up is this little block called remote state. Now, this is where Terragrunt really shines. It dynamically sets up the Terraform backend. That's just the place where Terraform keeps track of what it built. Instead of you having to hard code S3 bucket names and all that junk, Terragrunt just generates them for you based on stuff like the account ID. This is literally the thing that guarantees dev state and prod state never, ever touch. So let's break down what that one block gives us. Boom. Total isolation. Every account gets its own S3 bucket. Simple. Safety? You get a DynamoDB table that stops two people from trying to change the same thing at once. And security? All your state files are automatically encrypted. Just like that. The whole nightmare of managing state files by hand, it's just gone. All right, next up is the generate provider block. Now, this is a huge one for security. It's how we get into each AWS account without scattering secret keys all over the place. Instead of using permanent IAM user credentials, Terragrunt creates a provider config right when you need it. And this provider tells Terraform, hey, just temporarily assume this specific IAM role in the account you're about to work on. It's so much more secure. And this is a massive security win. Why? Because it enforces what we call least privilege. That Terraform execution role only has the exact permissions it needs to do its job, nothing more. Plus, check this out. We can use this block to automatically tag every single thing Terraform builds. Think about it. Perfect for tracking costs and keeping things organized. And again, it happens automatically every single time. Consistency is king. And here's where it all comes together. We can easily enforce different rules for different environments. Look at this. In our dev account config, we might have backups and deletion protection turned off. But for prod, oh yeah, those are absolutely getting turned on. These variables get fed directly into our Terraform modules, which means our production environment is automatically, and I mean automatically, built with way stricter, safer settings than dev. No one can forget. Okay, let's talk about something really powerful from the world of DevSecOps: hooks. Now, what if you could force everyone on your team to run security and quality checks before they're even allowed to apply a change? I mean, make it literally impossible to skip. Well, that's exactly what Terragrunt hooks are for. So using something called a before hook, we can tell Terragrunt, hey, before you even think about running an apply, you have to run these commands first. So we make it run formatters, validators, linters for best practices, and here's the big one, TFSec. That's a tool that scans our code for security problems. So if your code is messy, broken, or has a security hole, the apply just fails. It doesn't even start. It's a brilliant safety net.
Okay, so we've laid out the blueprint. We've coded all our amazing guardrails. Now for the payoff. Let's see all this in action and deploy our secure VPC into the production account. And this is it. Seriously. You just cd into the directory for what you want to deploy, our VPC in production, and you run one command, Terragrunt apply. That's it. That's the whole thing. One command to safely roll out your hardened, fully compliant infrastructure.
But let's just pause for a second and appreciate everything that one little command just did for us. It loaded the right variables for prod, it set up the secure S3 backend and the DynamoDB lock, it generated the provider to assume the right IAM role, it ran all of our security checks with TFSec and TFLint, and only after all of that passed did it finally deploy our VPC. All of that complexity completely automated away. All right, so let's do a quick recap. What have we actually accomplished here? I mean, think about the transformation. We went from a super risky manual copy-paste workflow to something that's secure, automated, and totally scalable. We can now manage all our AWS accounts from one repo. We have guaranteed isolation for our state files. We enforce secure IAM roles for everything. We automatically apply different security rules for dev and prod. And we bake security scanning right into the workflow. This is how you build cloud infrastructure that's fast and safe. But this is really just the beginning. This is the foundation. We could take this so much further, right? We could build a central security baseline on top of this. Things like enabling guard duties, security hub, and central logging across every single account in the whole organization. So what do you think? If you want to see a follow-up where we build out that central security baseline, you gotta let me know. Just drop a comment below with security baseline, and hey, while you're at it, tell me which cloud you're using the most. Thanks for tuning in.